Table 310.16 of the National Electrical Code, NEC, is a crucial reference for determining the allowable ampacities of insulated conductors rated up to and including 2000 volts. This table provides ampacity values based on the conductor's insulation type and its operating temperature. Understanding how to correctly use Table 310.16 is essential for ensuring safe and compliant electrical installations. The table itself is structured with various columns representing different insulation temperature ratings such as 60 degrees Celsius, 75 degrees Celsius, and 90 degrees Celsius. These temperature ratings indicate the maximum temperature the conductor's insulation can withstand under continuous operation without degradation. The ampacity values listed in the table correspond to specific conductor sizes typically expressed in American wire gauge, AUG, or circular mils. When using Table 310.16, the first step is to identify the appropriate column based on the conductor's insulation type and its termination temperature rating. It's important to note that the termination temperature rating, which refers to the temperature limitation of the terminals or devices to which the conductor is connected, often dictates which temperature column to use. For example, if a conductor with a 90 degrees Celsius insulation is connected to a terminal rated for only 75 degrees Celsius, you must use the 75 degrees Celsius column for ampacity determination. Now, let's address the specific scenario of using the 90 degrees Celsius column as the starting point for derating. The 90 degrees Celsius column in Table 310.16 can be used as the initial ampacity value before applying derating factors under specific conditions outlined in the NEC. These conditions typically involve situations where the conductor is installed in an environment with high ambient temperatures or where multiple current-carrying conductors are bundled together. Derating, also known as ampacity correction, is a process of reducing the allowable ampacity of a conductor to account for the effects of increased ambient temperature or the presence of multiple conductors in close proximity. These factors can cause the conductor to overheat, potentially leading to insulation damage, reduced lifespan, or even fire hazards. The NEC provides specific guidelines and formulas for calculating derating factors based on ambient temperature and the number of current-carrying conductors. To use the 90 degrees Celsius column as the starting point for derating, the following conditions must generally be met. Firstly, the conductor must have a 90 degrees Celsius insulation rating. Secondly, the equipment terminations must be rated for at least 75 degrees Celsius or be identified for use with 90 degrees Celsius conductors. And thirdly, the derated ampacity must not exceed the ampacity permitted by the termination temperature rating. It's crucial to verify that the equipment terminations are suitable for the conductor's temperature rating. Many terminals are only rated for 60 degrees Celsius or 75 degrees Celsius, in which case you must use the corresponding ampacity column in Table 310.16. However, some equipment is specifically designed and listed for use with 90 degrees Celsius conductors. Once you've confirmed that the conditions for using the 90 degrees Celsius column are met, you can proceed with applying the appropriate derating factors. The NEC provides ampacity correction factors for ambient temperatures above 30 degrees Celsius or 86 degrees Fahrenheit. These correction factors are multipliers that reduce the allowable ampacity of the conductor based on the actual ambient temperature. For example, if the ambient temperature is 40 degrees Celsius and the correction factor is 0.91, you would multiply the ampacity value from the 90 degrees Celsius column by 0.91 to obtain the derated ampacity. Similarly, the NEC provides adjustment factors for the number of current-carrying conductors in a raceway, cable, or earth. These adjustment factors account for the heat generated by multiple conductors in close proximity, which can raise the overall temperature and reduce the allowable ampacity. The adjustment factors are also multipliers that reduce the ampacity value from Table 310.16. For example, if there are 7 current-carrying conductors in a raceway and the adjustment factor is 0.70, you would multiply the ampacity value from the 90 degrees Celsius column by 0.70 to obtain the derated ampacity. After applying all relevant derating factors, the resulting ampacity value represents the maximum current the conductor can safely carry under the given condition. It's important to ensure that this derated ampacity is not exceeded in the actual installation. Here's a step-by-step summary of how to use the 90 degrees Celsius column as the starting point for derating. Firstly, identify the conductor's insulation type and temperature rating to ensure it is rated for 90 degrees Celsius. Secondly, verify that the equipment terminations are rated for at least 75 degrees Celsius or are identified for use with 90 degrees Celsius conductors. Thirdly, determine the ambient temperature and the number of current-carrying conductors in the installation. Fourthly, obtain the ampacity value from the 90 degrees Celsius column in Table 310.16 for the appropriate conductor size. Fifthly, apply the ambient temperature correction factor from the NEC, if applicable. Sixthly, apply the adjustment factor for the number of current-carrying conductors from the NEC, if applicable. Seventhly, multiply the ampacity value from Table 310.16 by the ambient temperature correction factor and the adjustment factor for the number of current-carrying conductors. The result is the derated ampacity of the conductor. Finally, ensure that the derated ampacity does not exceed the ampacity permitted by the termination temperature rating. It is important to consult the latest edition of the NEC for the most up-to-date requirements and ampacity tables. The NEC is revised regularly to reflect changes in technology and best practices. Let's consider a practical example to illustrate the application of conductor derating using the 90 degrees Celsius column. Suppose you have a 12 American wire gauge AUG copper conductor with THHN insulation, which has a 90 degrees Celsius rating. This conductor is to be installed in a raceway with 8 other current-carrying conductors, and the ambient temperature is 40 degrees Celsius. The equipment terminations are rated for 75 degrees Celsius. First, we verify that the conductor has a 90 degrees Celsius insulation rating, which it does. Second, we confirm that the equipment terminations are rated for 75 degrees Celsius. Since the terminations are rated for 75 degrees Celsius, we can use the 90 degrees Celsius column for derating, but the final ampacity must not exceed the value in the 75 degrees Celsius column. Third, we determine the ambient temperature, which is 40 degrees Celsius, and the number of current-carrying conductors, which is 9. Fourth, we look up the ampacity value for a 12 American wire gauge AUG THHN conductor in the 90 degrees Celsius column of Table 310.16. The table shows an ampacity of 30 amps. Fifth, we find the ambient temperature correction factor for 40 degrees Celsius. According to the NEC, the correction factor for THHN conductors at 40 degrees Celsius is 0.91. Sixth, we find the adjustment factor for 9 current-carrying conductors in a raceway. According to the NEC, the adjustment factor is 0.70. Seventh, we multiply the ampacity value from Table 310.16 by the ambient temperature correction factor and the adjustment factor for the number of current-carrying conductors. The calculation is 30 amps times 0.91 times 0.70, which equals 19.11 amps. Therefore, the derated ampacity of the 12 American wire gauge AUG THHN conductor under these conditions is approximately 19 amps. Finally, we check that the derated ampacity of 19.11 amps does not exceed the ampacity permitted by the 75 degrees Celsius column. Looking at Table 310.16, the ampacity of a 12 American wire gauge AUG conductor in the 75 degrees Celsius column is 25 amps. Since 19.11 amps is less than 25 amps, the derated ampacity is acceptable. In this example, we successfully applied the derating factors using the 90 degrees Celsius column as the starting point. It is important to remember that derating is a critical aspect of electrical design and installation. Failing to properly derate conductors can lead to overheating, insulation failure, and potentially dangerous situations. Always consult the latest edition of the NEC and follow the manufacturer's instructions for equipment and conductors. In addition to ambient temperature and the number of current-carrying conductors, other factors can also affect conductor ampacity. These factors include the type of raceway or cable used, the presence of thermal insulation, and the operating voltage. The NEC provides specific guidelines and requirements for addressing these factors. When working with electrical systems, it is always recommended to consult with a qualified electrician or electrical engineer. They can help ensure that the installation is safe, compliant, and meets the specific needs of the application. Understanding conductor ampacity and derating is essential for anyone involved in electrical design, installation, or maintenance. By following the guidelines and requirements of the NEC, you can help ensure the safety and reliability of electrical systems. The proper application of Table 310.16, including the use of the 90°C column for derating when appropriate, is a key element of safe and effective electrical work. Remember to always prioritize safety and consult with qualified professionals when working with electricity.